Okay, share my screen. So, we discuss about the sensors, no? The sensor actuator and smart object, no? The sensor has capability to send data through the internet, send measure, physical measure using the network. The actuators can receive a message through the internet or through the network, process this message and apply some physical actions. And the smart object is a device that has sensors and actuators that can interact one to others, okay? The second component on the second stage is the gateways and data acquisition. Remember then this device has very constraints. It's a very, or don't have a power processor, cannot expend a lot of energy. Most of the time, this device use very simplistic protocols to send data. It's not sophisticated like, for example, WhatsApp, like, for example, streaming videos, things like that. Sometimes yes, but sometimes no. You can use an IoT gateway to, for example, translate this protocol to the cloud protocol. For example, the REST protocol that is a more advanced. For example, this device does not have, for example, a lot of security features, okay? But in the cloud, you have very advanced security protocols. And you can use this IoT gateway to translate this device, this environment to this environment, and the information from the cloud to the device, okay? But again, a lot of times, this layer or the gateways and data acquisition is used to connect sensors, network, and the internet, okay, enabling IoT communication. A lot of time, this device only provides the protocol translation or to some security, okay, provide some security to this device. Today, okay, this device, the data gateways and data acquisitions alone is very common in the legacy implementation of IoT, or in other words, in the old implementation, not newest one, okay? Because in the newest one, you use the edge. Yeah, I have one video. I'll just check if I share with the sound. I have some video about the edge. It's a very nice video. I believe you understand. And after I explain again, okay?
As IoT and digitalization of business grow, there are increasing challenges of managing large amounts of data. Edge computing will be required to support this growing data load. Gartner predicts that by 2025, 75% of enterprise-generated data will be created and processed outside the cloud. Today, it's around 10%. The problem is that when being processed in the company's data centers and in the cloud, the network bandwidth reaches the limit, producing data agglomeration, slow response time, and excessive costs. How can companies solve it? And why should they do it? Edge computing enables data produced by IoT devices to be processed closer to where it was created, rather than send over long journeys to reach data centers and clouds. Instead of traveling to the cloud, data is processed, analyzed, and filtered directly on or near the device. Edge computing allows companies, governments, and organizations to obtain numerous benefits, such as real-time data analysis, greater security and privacy, latency reduction, lower bandwidth consumption, less data storage in the cloud and company servers, lower energy consumption, fewer bottlenecks in data traffic. Let's take a look at some use cases. Latency reduction. Edge computing enables increased processing speed to respond to changes in situations, such as biometric monitoring of health issues, automated control of drones or other situations that require under 10 milliseconds latency. Bandwidth and data filtering. You do not need to send all the data. You only send what is important. An edge device is able to filter everything but important data and send alerts to centralized data centers reporting the problem. This is a more efficient model. Take the next step in your digital transformation. Vantic. Innovate faster. Operate smarter.
Okay. This video is a little marketing, but has information. But what is important to understand is the edge layer is the layer that provides advanced service to the IoT device. Okay, different than the gateways. One edge device provides the same service than the gateways provide, but much more. Okay, for example, again, you can analyze the data that the device sends and provide real-time reactions. For example, fix one, you have one machine that you monitor the parameters of this machine. And if you send the data to the cloud spend a time to process this data, for example, for this data, it will be transported through the internet until arrive in the cloud, and the cloud process this information and reply with, for example, a reaction. Because the edge is close to the device, is close to your network, the edge layer provide real-time reaction. For example, you measure a lot of parameters. You can have some machine learning algorithms, not so advanced, but simplest one, some rules, for example. And if the data is outside the threshold, outside the threshold that you define, you can react immediately. Okay, you can react in real time to provide real-time behavior or real-time analytics. You need to implement in the edge, not in the cloud. To the cloud, you can provide very powerful analytics. Okay, you can define the threshold. You can identify, for example, when one machine needs to have one maintenance. Okay, you can in the cloud, but in the edge you have real-time reactions. Did you understand the difference between what you can do in the cloud and what you can do in the edge? Yes or no, guys?
Yes. Yes.
Okay. This picture is nice. See this picture here, guys. Here, check the time. Okay. Here you have the IoT device. Okay. In the plant. Here you have the plant. Okay. And what you have here, the device send data, receive commands, and here in the plant you have the IoT edge device. And the IoT edge has its implementation Azure, okay, in the Microsoft cloud. You have the Azure String Analytics on IoT edge, okay. This model here receives data from the cloud, filter data, and send the filtered data to the cloud. In the cloud, you have the same model, Azure String Analytics. But this one is more powerful because you can use thousands of servers. Here, no. Here it's like an appliance, like a router that you see in your home. Okay, it's not exactly the same router. It's more powerful. It's clear, but it's not like, for example, 1,000. It's not a cluster of servers. It's our own device. Okay, so this device can do the same thing, but can process, can have some analytics powerful, and can provide real time. For example, can react immediately when you suffer. For example, one equipment is very high temperature. You can turn off immediately this equipment to protect the equipment. In the cloud, you have more advanced. For example, you can use machine learning, time series, and others features that you can provide more powerful algorithms, but not real time. Okay. So here you have the Azure cloud. It's a cloud from Microsoft. Okay. This cloud is the cloud that we use in our course. Okay. So again, the edge is located closer to the data source, okay, in the physical terms, okay, it's in the same place, okay. Only the large chunk of data you really need to power off the cloud to be processed and forward. If you don't need, you don't send, okay. And it can provide security and reduce the power and bandwidth consumption in the cloud because you have more efficient approach. Remember, the gateway does not provide it. Benefits: decrease the cloud network load, reduce the transmission cost, real-time response to the things, and provide monitoring and IoT device in their activities, okay, in real time. Finally, you have the cloud. Clouds provide a lot of managed things, okay? Remember, the cloud is an infrastructure that has a lot of powerful service, okay? Remember, for example, the cloud from Google, it's a lot of service distributing in a lot of places to provide power, okay? It's different than that, okay? The cloud can provide, store, process, and analyze massive volumes of data. For example, you can have multiple plans, each plant with your edge, and in the cloud integrate all of the plans, okay? I will back to our reto. Give me a second. Okay, it's the picture of our reto, no? Here you have here you have the device, okay? If you see, if you analyze in this four-stage architecture, this layer is the sensor and actuator layer. In the edge, you have the drones, because the drones provide the connectivity, but not only the connectivity. The drones can, you'll see the implementation that you use, the drones can work like the edge device. You can have the drones like the gateway, or you can have the drones like a edge. You defining the implementation, okay? And you have the cloud. I believe now these pictures make more sense than the beginning. Am I correct?
Yes, yes.
Okay, guys. Back to the presentation. Okay. There are four types of clouds. The public one, like Google. The private, it's a cloud that you install in a company. For example, in Brazil, Force has a private cloud. A community is a cloud, is a public cloud that the people provide to a specific things. For example, a community cloud is the GitLab, for example. You have the hybrid. The hybrid is a private cloud that's running inside the public cloud. For example, you can buy, you can configure inside the Google or the Microsoft or the Amazon a private network in a private cloud. It's a cloud that works in the public infrastructure, but you use a security scan that it's like you have your only private cloud. It's a hybrid, okay? The main technology that a cloud has is the virtualization, okay? Virtualization, in the generic way, it's a technology that you try to virtualize a hardware, okay? For example, when you use a VMware or when you use a VirtualBox, you use a technology that try to virtualize the hardware. For example, when you use a VirtualBox or a VMware, do you know who? I believe everybody already listened about the VirtualBox or VMware. When you use this technology, you have the hardware, no? The real hardware that is here, okay? This hardware has an operation system like Microsoft Windows or Linux. And what the VirtualBox has, or VMware has, is an hypervisor layer. What this layer does? This layer provides a translator from the real hardware to the virtual machines. When you install, for example, a Linux machine using a VirtualBox, the Linux machine is here in this layer, okay? And you use the hypervisor of the VMware or the VirtualBox to translate the call and to emulate the hardware to this virtual machine, okay? You don't have access direct to the hardware, okay? You don't have access direct to the operation system. It's the reason that you can run a different operation system here above, okay? Another important, another approach is the container. The container is, for example, you use container here in our course. I believe I'm not sure, maybe you use, maybe no. I try to don't use to don't make more complex our course, but maybe you need. You have a container. A container is close to the same approach, okay? You have an infrastructure, you have operating system, okay, in the machine, okay, Windows, Linux, but you don't have in the hypervisor, you have a container engine. A container don't have the gas operation system, okay? For example, you can develop an application, okay, in Java or in Python or the JavaScript using the Docker, for example, and you don't need to install the complete operation system to run. You only install, you run directly, you package the application in a container and run directly in the container. The benefit of this approach is that your application is so lightly than to use a regular virtualization. Okay, it's not the goal of this course to explain in detail this technology, but only you need to know is that it exists. Okay, any questions? No? Okay. You have four cloud-based service models. The simplest one is the infrastructure as a service. In this approach, you buy a virtualization space like that, okay? You buy a space in the cloud to run a complete machine, okay? For example, you go to the Amazon or Microsoft and buy a Linux machine, and you receive a complete Linux machine. It's infrastructure as a service. Another approach is the platform as a service. In this case, you use an external service from the cloud. For example, you can use the GitHub, okay? Another one is the software as a service, is what you use a specific software in the cloud, like the Microsoft Outlook, Microsoft Office 365, okay? Or you can use a desktop as a service. The first example, it's the explanation, but I'll show here, okay? It is when you don't use the cloud, okay? You have the hardware, and if you, for example, you need more hardware, you need to buy the hardware and install the complete hardware in your machine, in your infrastructure. You need to manage the hardware, you need to manage everything. When you use the ES, this hardware is provided by the cloud, and you install only the operating system, and you have a virtual machine inside the cloud. For example, you don't need to worry about the space. If you for example, stop the space, you need more space, you buy a new space in the cloud. But in this case, you only think in the operation system to above. And the platform as a service, you don't need to worry about everything in this layer. You only need things about the application. It's, for example, when you run the containers. And the service as a service, you don't need to worry about nothing. It's like when you use the Office 365, you don't need to, you only use the system, okay? Some examples of this type of application. When you use containers, for example, you can use the KVM, the OpenStack clouds, okay? It's in this layer. When you use, for example, you buy, for example, in the Amazon to have a server. And the platform as a service is like you have the GitHub, the GitLab, the Docker, okay? You don't need about the hardware, the operating system. We use a service to run, okay? You use a service directly. And the service as a service is above, okay? It's of 365, for example, it is when you use the machine learning service that the cloud provides. Another service is the desktop as a service. It's important, for example, when you need to have the same, for example, you have a call center. The user in the call center, the good idea that the technical guys that you work in the call center don't change the configuration, okay? It's different than our computer. It's different than the programming computer, okay? In this case, a good idea is to don't have the desktop locally, okay? When the user login, he go to the cloud and download the desktop, complete configured, okay? Examples, you have the Amazon Workspace, VMware Horizon, and Microsoft Azure Windows Virtual Desktop. So you have different technologies to provide the cloud. For example, Amazon, Oracle, Salesforce, Azure, Google Cloud, and others, okay? We have this video, but before this video, it's not so fast. It's a big video. We return it here. But first, I would like to share the activity of the next week. Give me a second. I show here, where is the canvas? Okay. Okay, models. For the next week, you have a new activity, okay? This one. Oh, did you just see? Sorry. Did you see my screen? Yes or no,
Yes.
guys? Okay. So here you have the class today, you have the activity 622, okay? This activity is not published because I need to create the groups, okay? It's a group activity, okay? I created, after this class, I will create the groups and publish today this activity to be possible to access, okay? What is you need to do? You need to generate a report. It's different than the last class. The last class you generate a presentation. Now I want to generate a report. Okay?
Okay.
Sorry?
A what? A port or what
Report,
did you say?
report.
Report. Okay.
Okay? Sorry by my English, okay? A report. How you need to do? You need to read this document that I prepare, okay? You open here. Okay, it's a document that I prepare showing what is a smart house. Okay, explain what is a smart house. I give you some video that show an example of a smart house. Show what is a smart home things. You have some example of smart home things. Okay. The smart home control application show, for example, some examples of applications, some example of rules, okay? You read this material, and after it, you think about your home, okay? Okay, give me a second. What's the question? In the comments, yes? No creo. Give me a second. Oh. And this group is correct, guys? Is the same group that you passed to me?
I think so, yeah.
Okay, so I will share it down. So Teams, what's the name? Give me a second. Okay, now it's public, okay? It's public. Again, now you can see the activity. So you read the material, you think about your home and think, oh, my home has a door, my home has light. And what you need to do is think about your home and think the things that you can automate in your home, okay? You go to the internet and looking for example, to automate the lights. What you can do? I can use the smart socket from Google. A good idea is to go to Amazon or go to the Google and looking for device that you can use to automate your home. Okay, read the data sheets. Okay, to find the device. Okay. Use the course model, in other words, check this picture and think, okay, which sensor you use to automate your home, okay? The second age, you don't use the internet gateway, okay? You use an edge device, okay? Go to the edge and with the explanation and see here the automatization, okay? For example, in this document here, you have some rules. For example, if the door or window is open, so the control valve of the heating radiator is turned off, okay? You automate the air conditioner based in the sensor from the window, okay? You have another example here, okay? You think about the rules that you need to do, Think about which rules you implement in the edge layer, which rules you implement in the cloud layer. Go to the cloud, Google, Amazon, Microsoft, check which features you need that this cloud provides, and try to design an architecture, okay? What's important here? Don't spend a lot of time to try to looking for the correct feature that you need in the cloud. I'm not checking, see the video, checking select one cloud, Google, Amazon, Microsoft, try to see what is the feature this cloud provide, okay? But don't spend a lot of time. The goal is not it, okay? The goal is to find the device, real device that you can use to automate your home, read the data sheet and understand the features that you can use, okay? And try to create the rules, okay? Not in the programming language, in the Spanish or in the English, rules like that, okay? Very simply rules like that. And identify if you install these rules in the edge or install these rules in the cloud. Did you understand until here?
Yes.
Okay. So after each, you create a report, an introduction, where you define a smart home and how IoT can be used to improve the family's well-being, safety, and security. You have a development that you show the IoT architecture and explain it. A final remark with a conclusion, show the limitation of your documents. For example, you don't spend a lot of time to define how to use the Microsoft Cloud to implement it. You see here, you show here, oh, my research is very superficial in the cloud technology, but you try to, you finalize the documents, okay? And use the reference using the MLA style, okay? The MLA style is here in the schooler, okay? In other words, go to the schooler, for example. If you use, I don't know, for example, think that you use this document here, okay? You go to site and check here, oh, MLA. You just copy here and save in the document, okay? How do I evaluate your documents? Here is the rubrica, okay? You read the rubrica, I use the rubrica to evaluate the groups. Any questions?
No, Professor.
It's very important, okay? It's a very short report, okay? No more than 4 pages, okay? Short report, okay? It's not to work 1 week in this report. It's very simplistic task, okay? The important thing is read this document to understand what is a smart home. Go to the Amazon, Google to find, for example, I would like to automate my the air conditioner. Which type of air conditioner it's IoT device? Looking for example, IoT air conditioner. Appear Samsung, LG, and another one. Check the data sheet. Looking for information and use this information to define the architecture. Okay. The third task. Read again the material that I published, that I shared with you about the edge and the cloud, and look for about the features that you need to implement in the edge. Okay. For example, you can, for example, as I told, create real-time rules, no? And if you have real-time rules, these rules, create the rules in English or Spanish, okay? And say, oh, I use this rule in the edge. Oh, this rule is not to real time, it's more to maintenance, it's a long time. Okay, this rule I implement in the cloud. Did you understand again, it's not to create a final report, okay? I don't, it's not my expectation to have very technical details about, for example, oh, I use like in this slide here, I use, for example, the model Azure String Analytics. No, I don't, it's not my, I don't expect to have this level of detail. Not now, okay? In the future, yes, but not now. Did you understand? Any questions? No questions?
No, teacher, everything is okay.
Okay, perfect. Back to here. Okay, we have 50 minutes. Before I show again the video, give me a second. What is my presentation? I would like to ask you if you have any questions about anything that you discussed today. No? No question, guys. Okay.
No.
The courses make sense to you? Did you understand my English? Okay. You can really understand the blocks of the blocks that I try to build. If you see, I start very high level. Not today, I increase a little more details, and during the course you increase the details. This approach is okay to you? The science is not, I don't know if the science is good or bad, huh?
No, everything good, teacher.
Okay, guys. So I will start this video. Okay. I don't think so. We can finalize this video during the class. My suggestion: this video is you have in the presentation. This video is in the Canvas. Okay. My suggestion to you: before you start to work in the activities, finalize this video, okay? This video is a very big picture about the AWS, the Microsoft Azure, and the Google Cloud, and try to show the main difference, introduce some concept, reinforce a lot of things that, we discussed today. This video reinforce, okay? My suggestion, before we start to realize the activity, you'll visit this video, okay? I will start the video. I need to check if I share the audio. Yes.
Today's top 3 tech giants, that is Amazon,
Sorry.
Microsoft and Google have their own cloud platforms out there, and their names are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Hey guys, this is Shubham from Intellipath, and in this video, I'm going to compare 3 of these cloud giants and discuss which one to choose. So, without any further delays, let's get started. Let us just start from the basic and discuss each service in a brief. Amazon Web Services is the oldest and the most experienced player in the market, as it was established at the beginning of 2006. AWS has an extensive list of computing services with functions of deployments, mobile networking, databases, storage, security, and many more. Whereas Microsoft Azure was presented in February 2010, and since then it has shown a great promise among its rivals. This platform can easily be associated with AWS, and both provide their customers with a full set of services in the domains of compute, storage, database, networking, and many more, just like AWS. On the other hand, Google Cloud Platform began their journey on October 6, 2011, and by this time they have managed to create a good presence in the industry. Initially, the push was to strengthen their own services such as Google or YouTube. But now they have moved further and they have also created the enterprises services. So now anyone can use their cloud platform which shares the same infrastructure that of Google search and YouTube. But still, the question remains, how are these three cloud services different and what are the factors that we need to focus on while comparing three of these services? Well, we are about to discuss that as we move forward. Let's just start from the first factor, that is the availability zones. Before discussing this factor, let me give you a brief introduction to availability zones. Availability zones are the isolated locations within data centers regions from which public cloud services originate and operate, and the regions are the geographic locations in the data centers where public cloud service providers reside. Basically, businesses which are using cloud choose one or multiple worldwide availability zones for their services depending on their business needs. So they select the availability zones for a variety of reasons, including compliance and providing proximities to end customers. Cloud administrators can also choose to replicate services across multiple availability zones to decrease latency as well as to protect their resources. Admins can move their resources to another availability zones in the event of blackout. Certain cloud services may also be limited to particular regions or availability zones. So now we are all aware of their establishments. We all know that AWS was the first one of its kind, right? Which means AWS is hosting in multiple locations worldwide. And of course, it is true for Azure as well as for Google. But here also, the difference occurs in the numbers of regions and availability zones. Talking of number, AWS has 55 availability zones worldwide with 8 more on its way. Whereas Azure is having 44 availability zones with a whopping number of 12 more on the way. On the other hand, Google is having 18 availability zones with 3 more on the way, which is no doubt is quite a lesser number than AWS and Azure. Now let's move forward and talk about the next factor, which is the market share. So guys, if we check this graph right here, which clearly depicts that how AWS is leading with 40% of public cloud market shares worldwide on its name, whereas Azure is on the second place with 30% of the market share, and Google Cloud, which is not that behind, is on third place with 10% of the market share, and other cloud providers combines at 20% of it. And guys, let me tell you an interesting fact here, that according to a recent report by KeyBank, Amazon lost almost 6% share while Microsoft Azure moved from 26% to 30%, and Google successfully jumped its share from 8% to 10% in the cloud business. Also, if you check the Google Trends graph and compare their popularity, these are the stats where you can easily figure out that how interest for AWS has been surpassing with Azure on second place and Google on the third worldwide in the past 12 months. Even if we check the research results and trends according to USA, same cases here as well, where there is more interest for AWS than Azure and Google Cloud. In case of India, here are the results. Still, AWS is more trending. These are the results from past 12 months and have been varying and relatively increasing with AWS on the first and Azure on second, Google Cloud on third from a past decade. We are all aware about the establishment of AWS now as a first cloud provider, right? And with the more experience and implementation in the cloud domain, it obviously has a bigger community support and trust across its clients. And with Azure and Google Cloud, well, they have been able to cop up trust across their multiple clients successfully. So let's check what type of companies are using them. AWS is having more profile customers like Netflix, Airbnb, BMW, Unilever, Samsung, Xiaomi, Zynga, etc. And Azure is also not that behind, as almost 80% of Fortune 500 companies have put their faith in Azure recently. Some of its major clients are Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, etc. Since Google shares the same infrastructure that of Google search engine and YouTube, that is why many huge companies are having faith on them. And some of their major clients are HSBC, PayPal, 20th Century Fox, Bloomberg, Target, Domino's, etc. No doubt, AWS is dominating public cloud over Microsoft Azure and Google in this race, but they both are also growing continuously to be at the top. So guys, don't you think it is quite impressive for Azure and Google to be on the top runner list even after being a latecomer in the cloud domain? Right. Now, after discussing their establishment in the market, let's talk about what each provider has to offer in terms of services. So guys, the services which I'm going to compare here are very primary and comes under the following domains. That is the compute, database, storage, troubleshooting and monitoring. So AWS covers like 200 plus services and Azure also covers 100 plus of it. Whereas Google Cloud have been catching up with it with a number of 60 plus services. So now let us compare the primary services in each of these domains. I'm not covering all of these services since there are so many services in each of these domains. So in the compute domain, the primary service offered by AWS is EC2. In Azure, it's virtual machine and Cloud Engine for Google. So basically all these three services help you in launching instance on cloud. Like if you want to run a virtual machine or an operating system without an on-premise infrastructure, you can do so with any of these services. They all have the same idea, same working with the same functionality. Just the names are different. But there is one major difference, that is the speed of launching an instance. Well, if you try to launch an instance in three of them, AWS will take around a minute to launch an instance. In case of Azure, it takes more time to do so. But guys, in case of Google Cloud Platform, well, it takes seconds to launch an instance. This is where Compute Engine comes out to be a preferable choice. Now, another service comes under database domain. The primary database service provided by AWS is RDS. That is a relational database service where the databases like MySQL, MariaDB, Oracle, which can be managed automatically, like backup, security patches, and updates are done automatically by RDS. In case of Azure, there is a primary service called as SQL Database Service. Well, in this service, you cannot choose any like MariaDB, Oracle, or MySQL databases. So you can only choose SQL database. And you need to change your application code to be compatible with SQL databases if you are using Azure. Even you have to configure everything on your own. No automated updates facilities here. Now in case of Google, we have the service named as SQL Database, wherein you don't have the provision of choosing any other database apart from MySQL database and PostgreSQL. Now let's discuss the next domain, that is the storage domain. The primary service in AWS storage is S3. So this is the simple storage service, which is an object-based file system. So whenever you are storing your file on these systems, these files can be treated as an object, and S3 consists of buckets, which further consist of root folder, and one can store their objects inside these root folders. And Azure on the other hand implemented this similar idea. Its primary storage service named as blob storage, which is an object-based file system where the files are stored as an object. Well, in case of Google, cloud storage is the service, and again which provides you the similar kind of object-based storage system. Moving forward with the another
Guys, I need to stop because you don't. You need to finalize the session. So please watch this video. Don't worry if you didn't understand completely what you're talking about. We have the opportunity, not the next class. Next class we'll talk about the network part, but 2 classes ahead we'll have a not only a class, but a class plus hands-on activity to use the cloud. We define the concept. We use the Microsoft Cloud, okay? And we have academic account. Don't need to use credit card, okay? And we'll configure a device, an IoT device, an IoT environment from scratch, okay? And we have this class. But again, watch this video because this video don't talk about only the Microsoft, but talk about the Google and show the difference. In our course, we will only use the Microsoft because you don't have time to discuss the Google. The Microsoft is okay. For example, Amazon and the Google don't have the academic account, and you need to use the credit card. Okay. So, but please watch this video because show about a lot of things. Not so big. It's 15 minutes. Okay. And I believe it's very important to have an idea about the cloud technology, and it's very useful for the next class. Okay. Any question, guys?
No, teacher.
Okay. So, guys, I hope you like the course. You are liking what you're doing now, and I'm very happy to teach you. My expectation is very big with your group. Okay, so thank you very much for today. Please, if you have any question, use the Slack to ask me, and have a great weekend. Okay, guys, see you next week.